Good afternoon, everyone. Welcome to my presentation. My name is Narottam. The title of my presentation is Delivering Technical and Project-Based Learning Courses in Face-to-Face and Distance Modes for Higher-Level Engineering Students. Learning outcomes: after successful completion of this module, you will be able to design and analyze the performance of single-phase transformer, cost analysis of single-phase transformer design for sustainable power industries. Understand the significance of project-based learning in real-life application, that is industry-based. The outline of my presentation is introduction, single-phase transformers and its design parameters, performance analysis, cost analysis of single-phase transformer design and for sustainable power industries, and project-based learning and its significance in real-life application. Finally, the conclusions. Face-to-face learning and PBL. What is the difference? We will discuss about this one. Face-to-face learning is an interactive teaching method where trainers and students meet in a classroom for a specific duration of time and then discuss. It includes lecture, tutorials, assignments, and final exam. PBL is a teaching method where students gain knowledge and skill by working extended period of time to investigate and respond to and engaging complex questions, real-life problems and challenges. It includes group work, seminar, workbook, records, reflective journals, and finally the portfolio presentation, portfolio submission. So what is transformer? This is the question. Transformer is an electrical device, transfer electrical energy from one circuit to another circuit. Transfer of energy may occur in the same voltage, and purpose of transformer is isolate two circuits. Transformer accomplishes these changes in voltage without the use of moving parts, and its cost per kilowatt is low and efficiency is high. In general efficiency of transformer 98 to 99%, there is no moving parts and maintenance is simpler and it is cheaper. So far, transformer has primary and secondary. So the coil or winding, it often called, so who is received the energy is primary side, and this side has primary side voltage V1 and turn number of turns N1, and then similarly we have there is energy delivered to the load is the secondary side, and this one has voltage V2, number of turns is N2. So in an ideal transformer, there is core type and shell type. Then we have to find out the voltage ratio. We need primary side voltage and secondary side voltage. This is primary side voltage, secondary side voltage. If we take the ratio, V1 over V2, we will get N1 over N2, and A is the turn ratio of transformer. If A is greater than 1, then we can say a step down transformer. If A is less than 1, then we can say it is a step up transformer. And the current ratio of transformer can change voltage, but power and volt ampere on both sides are remain same. We can see from this one, primary side volt ampere, secondary side volt ampere, we get this relationship. And then number of ampere turns also remain same on both sides, ampere turns, primary side and secondary side is the same. So far, for understanding the voltage ratio, number of turns ratio and current ratios. Current ratios is opposite relationship than voltage ratios and turn ratios. Then we want to do one example. We have given problem, have to find out the full load current on primary and secondary sides. So far, primary side current full load we can get using this calculation, and secondary side using this one. And then we are coming to the equivalent circuit of single phase transformer referred to primary side. Primary side, so transformer, it has equivalent resistance and reactances. So we will get the primary side and secondary side. And turn ratios here N1 and N2. So we will get the secondary side resistance, reactances, voltages, and currents using these equations. And another example that is useful for design, that's why we have to solve this example. Solution is here, we're referring to primary side, and then calculating resistances and reactances. Therefore, we will get the primary side this one, and then secondary voltage using this power factor is here, and then full load condition we will get V1 and V2 using these formulas. Therefore, we are coming to transformer losses and efficiency. Every device there are losses. Transformer also two types of losses. These losses are iron loss and core loss, represented by these equations, and then transformer efficiency represented by this equation. Wherever input power, how to get it, input power is linked with your output and losses, and these losses also again includes with your iron loss and copper loss. So far, we can use this equation to calculate the efficiency of the transformer. And full load condition this, and then different factors. We will consider different parameters, and we can calculate the efficiency of the transformer, the performance of transformer. Then we are coming to voltage regulation, that is determines the voltage drop between no load and full load operation. All parameters are referred to primary or secondary. Voltage regulation can be represented either down voltage regulation or up voltage regulation. Down voltage regulation always with referring no load condition. Up voltage regulation is full load condition. And then coming to project-based learning, PBL is the way to have students become directors for their own learning, and teachers become the guide, not a taskmaster. Students work hard and solving the real world problems by themselves, and everyone should perform a role and support the final project. It's a high expectation, carrying relationship, meaningful participation, and flexible for the learners. The process of PBL includes group of work, and then Edmond or virtual school, reflective journal, crafting the driving questions, planning, and group presentation. Then I'm coming to the comparison of traditional and PBL modes. This is traditional, this is PBL. Just example, it is enjoyable, active, hands-on learning for traditional on, but PBL engaging emotionally and intellectually hands-on experience. Then for traditional on, product assist, but product and process assist for PBL, and school world products, and then real world process and products for the PBL. So far, the assessment process for face-to-face and PBL. Face-to-face should submit their assignments and final exam. PBL keep their workbook record through a reflective journal. At the end of the semester, they will submit their portfolio. And finally, the conclusion of this presentation, design of single-phase transformer for power industries, performance analysis of and cost analysis of the transformer, comparison between traditional and PBL approaches for high-level engineering students. For this presentation, I used the following references. So what would be the expected efficiency of a transformer? This is a question. Hopefully you understand that one. And if you have any other question, feel free to ask me. Thank you very much for your attention.